Okay, this probably is going to be one of the shortest panel discussions of ours.
Huh?
You know why?
Why?
We're at a Go conference. Why would there be any errors? Right? I mean, why would you have to handle any errors? Go is just incredible. And let me rephrase it. Does anyone actually write errors? Come on. No.
Wait, didn't you see my code? This never mind.
Yeah. Anyways, today we're going to talk about some of the best things you need to be aware of with error handling and Go. I'm looking forward to hearing this because there's some people that I know that know these things. In fact, we had some interesting tidbits just in the lightning talk with the interfaces. So we'll get into that a little bit. But first of all, let's just start out with why do I care? Why do I care about errors in Go?
They're going to happen.
Okay, they're going to happen. Okay, Carson knows they're going to happen.
To the mic, Carson.
Oh, I'm sorry. Because they're going to happen.
Turn it on.
Oh, wait.
Error, and we are going to handle it right now.
Really drill this in. We care about errors because errors are going to happen.
What is going to happen?
Also, all of the time, technically, at any point,
you just
right?
don't know, right? That's the key with errors. You don't know. Now, some you can plan, some you can't. So let's just talk about it. I'm gonna ask. I always love this. Who loved the job? Who loves? I said it in the past, which is really past for me now. Who loves the Java way of error handling? What do you do? What's the Java thing?
Exceptions.
You punt, right? You just kick it up, right? And then you just that huge thing, right? That's the Java way. Come over from Java, .NET, some of these other languages, and you go into Golang, and you go, oh, this is kind of a growth way of doing it. I wish I had that way of throwing it up, right? So, first question. What's the best way to handle errors in Go, and why is it so, at first, feel so weird?
I'll start with the mic. We handle errors by receiving them when they happen, right? Well, in two ways. There are panics. Panics still happen. There's still differs that you can sort of emulate and trying to catch. But we actually receive our errors as data for errors that are common, right? And we don't, I don't know. My first point I want to get on this is we handle it that way because in Go, we are programming defensively. My biggest problem with try and accept, or catch, whatever you want to call it, is that it's optimistic coding. It's just assume everything's going to be fine. And what it leads to is you missing out on catching kind of halfway states. So my biggest beef with it is you're like, well, just throw it up. And like, then you really don't have to think about what if I'm halfway through, I write a file and I'm going to write two files and then the second one fails and I leave some garbage around. Try catch you don't even have to think about, right? Go, you at least have a place where you go, I'm about to return here and I'm looking at the function. I just did one thing. Like if you do try and catch, you start to think everything is just sort of like a transaction and it's not. So by getting those errors, you have to think about them all the time.
Errors are values, and so you can check them and you can check for the error right where it occurs. And it makes it so that you can proliferate that back up in the stack and find where there.
Okay.
I say is that if you do the other languages, you have to have if else's on that. Do I know this is true or not? And so you just say, if error is one of the return values, you could say, did an error happen early? And then you don't ever have to have else in the code because you could just say, an error happened, return, and then do the happy path for us. So with returning errors as you go, you have all happy path code on the left. And you don't have to have 12 indentation. Do try catch, or if this, if that, because it's all happy path once you've handled the errors beforehand.
Okay, so what we've heard is Go is
Happy.
the happy path. We're happy. We're happy because we use Go. Okay, I like that. So let's have some honesty here. First time you saw Go, programmed in it, and you had to deal with errors. What did you think? Did you like it? Huh? Come on.
Absolutely not.
Okay. Absolutely not. Thank you for your honesty. Others?
Loved it. I knew exactly where failures might occur.
Loved it, but kind of, okay. You knew exactly what's happening.
I didn't know any better because Go's my
You
first.
didn't know any better. That's the Go way. It's the happy way. God.
Uh-oh.
It was better than C.
Well, okay.
It was ugly and verbose.
Ugly and verbose.
Every time I hit a function, I had to handle an error.
You had to do something. I mean, you actually had to know what was going on. Yeah, and that's what I found. Okay, so you mentioned it. Let's talk about panic. Who likes to put panic in their code and why? AJ.
I like to put panic in my code because it's code that should never be reached. And if it is reached, it should panic.
Okay. What do you think?
Yeah, I agree. There is a time and a place absolutely for panic
Okay.
and recovery.
Where's the time and the place?
When exceptional things happen, you can basically emulate the exception model, right? There are places where you say, like, if we get to here, everything is so far beyond saving that I would rather just exit the entire program potentially than try to recover.
There are differences?
Yeah, I agree. We had a case where we were wrapping a database update in a transaction. And if there was a panic, we would try and recover and roll back. But if the rollback failed, we'd have the panic.
Okay.
So it would be better in that case to terminate than continue with bad
Be
data.
done. Okay. Jason?
I heard one, but somebody wants to tell me the only time you panic is if somebody else already panicked in the code and you can't read what their panic is, and so you panic to make it more verbose. So you recover and then tell what the panic is actually doing for your code, and then pass it from there.
That's truly a panic attack.
You don't need to.
Okay. All
Most of the
right.
time you don't.
We had a comment.
Panic is great too when not just because like you don't want to continue, but when continuing would risk loss of data or damaging hardware in a really horrible sense. Something where it's like it's really better to just stop than to do anything else because you might break something that you can't recover from.
So it's better to be dead than just to kind of, right?
Well,
Okay. It's Halloween, so I'm just thinking about it. Take others with you? Okay. No, I don't know about that.
I typically don't write too many panics in my code, but I heard as I was learning Go and some patterns that I was looking at, like the idea that there are certain functions that if, like, you know, in the startup of a service or something else, where if they do not succeed, you will be continuing in a state that's just not clean in the first place. Like a lot of times you would, you know, preference some of those methods with like the word must or something. The idea that this must happen, and if it doesn't, then you would.
Okay.
Yeah, kind of in the testing scenario, it's the fatal. It's the T-dot fatal. Like it's not worth going on. If this thing didn't succeed, just kill it, and we will be made aware.
So interesting pattern, perhaps, right? If we're testing code, which we should, whenever we think of that fatal, is that kind of the use case for a panic like that? It's kind of an interesting pattern. Frank.
Yeah, so this is just more of a general question again around panics. When I've encountered panics, as I've been trying to do code, it shows that I don't really know how to use the reflect package very well. But
That's okay, Frank. I'm just letting you know. Okay, it's okay.
But like that kind of feels like a totally different thing than saying, hey, it's not worth continuing on. I mean, maybe it does, but that feels like there's something. I mean, clearly you have to test your code and get that sorted out. But
I think that's one of the cool things about the defer recover thing is someone called them you want to poke recover refer, one to catch them all. So in your main, you want to have a Pokemon panic refer recover on the top. So that way, if you ever do have a panic in your code, you could actually log it out correctly and you'll catch it somewhere rather than just crashing your application. So if you have a if you catch it somewhere and then you log it right, then you'll be able to fix it later, as opposed to just your application being weird and not knowing what happened.
So now I know why they call it Pokemon Go.
Uh,
Chat.
that was funny. What I've learned from reading the standard library when they panic is that I see panics where it's a programmer mistake. If you can guarantee it's like a programmer's mistake, that's usually where I'll panic. It's very rare, but that's where I'll put a panic. And if it's an input or an external like IO thing or something, an error, then just normal handling. But if it's strictly a programmer's mistake, they did not read the documentation, they're violating this, like we spelled out very clear or something, then it should definitely be a panic in my opinion.
So the pattern principle is I use a panic when I feel really guilty as a programmer. But I want to ask you a quick question on that, and we'll get right here. You said libraries. How many love having a panic in a library that you don't know there's a panic in?
If, like I said, if I really messed up not using the library right, getting a panic right away can be really helpful.
But does everyone scan the library code to see if there are any panics to know if that landmine is going to be there?
Yeah, obviously have to be additional.
Huh?
You should recover liberally panic sparing.
Oh, in that space. Okay. All right. Sorry. Please.
I was going to expand on that where most of the time I feel like I use panic is in lieu of the compiler. So the compiler didn't check my regex that I didn't check my template that I parsed. So I'm panicking because I want to know about those things
because something happened. Okay.
Whatever sake.
Any follow-up kind of comments?
I was going to add, yeah, I totally agree with that. Like the must come and the programmer error, like the canonical examples of this are must compile regex, must compile, must load template, like things that like we're going to do this once we start the program. These are going to be critical things we're going to use a lot in the program. And I don't even want to start the server if this regular expression that I've heard, it's different when you're doing it as part of an input. But if you're just setting it as a variable at the top or loading it once, like, yeah, panic. Just say like, I can't, this isn't regular expression. Instead of failing when you try to use it, I'm going to fail really early on.
Okay. I'm going to ask a question then. So I had a good friend that when he would use a panic, it was very similar. And he would do it in the startup if I couldn't get a connection to the database. If I can't do anything with the database, why continue? Good pattern or not? Clint's going like, sure. Okay.
We try to reserve panics only for application setup. So I need to talk to SQS. I need to talk to my database. I need to make sure this file's there, right? If that's not there, I need to explode, right? And I need to alert the whole world. I think basically everything else is pretty much recoverable unless you're working with, hardware or anything weird like that. But I think for the most part, you can be recoverable basically everywhere else.
So if you're Kubernetes people, then there really should be alerts on crash loop backoffs. Is
Exactly.
what we're thinking.
Mm-hmm.
They actually mean something.
It's interesting because I feel like at the same time at the startup is like almost where you're the least deep in your code, and that's the easiest place to just log.fatal or just an OS exit and save the panic for where I don't know. I don't write a lot of panics, but I run into them because panic's a good way of the code letting me know that there is a path that was executed that I as a developer probably didn't account for.
I say I agree with that completely. I only I don't write panics into my code for things that are expected. And so a database being down is a log.fatal. It is not a panic to me because that's an expected path. The database can't be down. And so even the main, I only have fatals in the main function before setting up. And then panics are always just things that are completely unexpected.
All right, enough on the panic. But some really good tidbits here and probably some things to be thinking about in your own use cases and maybe your own patterns that you want to establish. Let's touch on, Carson talked about in the lightning talk, hey, here's package, interface. How do I kind of make errors good for me? Yeah, how do I give them value? How do I make them meaningful? And let's Just go
So-
across.
So I have a package I use for everything. I call it context error. And what it does is it lets you add fields to context, and then it's just a map of string any. And then when you have an error, you get all those fields back out. And so since most of our logs are JSON anyway, things like user IDs and like location error and stuff, I don't want that in a giant message in my log, but I want that available for when I have an error. So I put those all in the JSON instead of having them as part of the message. So my logs are readable and I can search for things without having to just giant 25 line just message. So I use like there is an interface to be able to pass in to a struct that I turn back to the JSON mesh.
For the most part, we use some really cool tooling here, I believe.
Yep.
Called
No.
W error.
Yep.
But I did find in some of our services that we do use the just error kind of native package error is to check for something that may not be considered an error. Like if you are, okay, for example, we do a transaction in the database. If it fails, we're rolling back. And as we roll back, if a record was never created and we try and delete it from the database, it's not going to exist. So to check for no rows and like SQL no rows as part of your error, and then you can move on confidently, because if you're trying to remove something that was never created, then that's okay, and we can continue.
So the error is and error has, no, as. No, two different ways of looking at it.
I have one last thing to add, and this is something. So I got back from talking about interfaces, and Brandon's like, so you take structs and you return interfaces. Or sorry, you take interfaces and you return structs, right? You take interface, return like concrete types. And I said, And he said, what about error? Here's an interface. You return it all the time. And I, like, my brain broke for a second because I'm like, oh, you're right. Like, there's this one glaring exception. And he said, should we just be passing like instead of returning an error, should we just be passing a struct back as a second item that happens to implement error, so it can be received by all the things that take error as a second argument, but internally within our code, we don't pre-abstract our errors. And I don't know yet. I haven't actually, I'm still in on that.
Okay.
So
Makes sense, makes sense.
You just think.
What?
Right, go ahead. You had to go.
is that what you do?
The reason for that is because errors aren't scoped in Go. And so you have an ERR and you can colon equal every time. And so if you return the struct back instead, if somebody tries to do an error.new instead of your special struct and that gets returned, then you're going to have a different type error. And so you have to do errors so that way, because error isn't a different variable every time. Unless you want to say this is the special error, this is a special error, this is a special error, and name them every time, then you wouldn't want to do that.
Talk about shadowing, like reusing the error variable.
Yeah, it's reused and shadowed without you even knowing it most of the time.
Olivia, do you
I was just stewing on that idea.
have anything? No? Please.
Yeah, something I was going to comment on, just the idea of returning your own error. A potential danger with that is if you happen to say, hey, if this returns type error, but you like implicitly change the type from your error to the standard error, when you go, hey, is this nil? It's going to say, nope, it's not nil. Or it's going to say that it's not nil, even though it technically is, because it fails the type check on the is nil.
Yeah,
I ran into that. It took me like 2 days to figure out why nil was not nil.
Brandon has an entire talk on that on the engineering blog. It's really confusing.
Right.
No, he does.
Yeah, it's up and available. Nil, it was not nil, but I think it is nil, but we won't. Okay, go ahead. Nil? Please.
I was going to say, I used to do that, but the reason why I stopped is because I found that for future safety, it causes a problem. It tends to make contracts more fragile. So maybe at this point in time, you're only going to return one type of error or one error value. But in the future, if that underlying function becomes more complex, now there's 2 error cases. If they don't fit nice in that type, you have to change to the general error interface. And then that breaks the contract.
But just internally in a package for private functions that are broken out. Like, I feel like that might be better.
Yeah, it depends on the layer of abstraction. If it's an internal tool, that makes sense.
In your package, want to do probably errors dot wrap. I mean, like wrap your error every time.
Yeah.
And so if you're wrapping, unless you have your personal package have a wrap function that handles it well, it's a little might be complicated.
But what I tend to find too is in small internal tools where you would pass a error type instead of an error interface that's very specific to that case, you're likely better off just returning a Boolean, because if your function is that small, it's either okay or not okay.
Yeah, I was just gonna ask, because in the, like, I came from C# and it was really quite nice when there was an exception, because the exceptions always had the specific type. You could say, oh, no parameter or set of bounds, or whatever, this type of exception. And so if you were calling that, you could expect that, and it became easy to test. And so when I started writing Go, I immediately gravitated towards typing the error and saying, oh, it's this type, it's an error not found. And I would type it because I found myself writing a lot of unit tests that would say, like, if the test should expect an error, does the error message have the right output? Like, I don't know. Maybe that's excessive testing, and I just wanted to get some feedback if people like this.
I mean, like, realistically, our tests, the value is that we're doing the right thing and we're getting use case to our users or when implementing our code. I'd say part of good errors is good messaging with that. I don't think it's a bad test. It's really just test.
Yeah.
I think it depends on who the error is for. If you're returning an error to the user, you want to have a kind of if there's something they can do to fix it, you want to give them a message how to fix it. If there's nothing they can do to fix it, you give them a 500, and then you have a good error. And so you need to, I think, like you said, one of the harder things with Go is that when they created errors, everyone just said return error every time. And eventually we decided that, wrapping your errors every time and giving more context to it as you return it up the chain is important to know. If you wanted your own error that creates a stack trace every time, you should probably do that, but it's better if you decorate your errors as they go up, then you know exactly what happens along the way, rather than just a random.
Anything else?
Can I add to that?
Please.
Yeah, so we actually made a tool for an internal team to join kind of two locations. And there's a lot of configuration and primitives that are created in this process. So we automated it, but errors and wrapping our errors and very explicit messages and tags was huge to identify quickly an issue when this tool was being used. If there was a failure, we could quickly trace where the error was happening, what the misconfiguration was, and make improvements on the model. So that the custom error package, which does a lot of the wrapping for us, is huge.
If you're throwing things up the stack all the way to the top and that's your only error handling, there are not even these touch points to add context along the way, unless everybody try catches everything all the time. And then that's actual code load, not just, I don't like to check if my error's not in.
Yeah.
Right? Like, having that context makes a big difference.
So I think it'd be very interesting to follow up this kind of discussion, kind of the maybe I'd use it, how I'd use it, when I'd use it, that kind of the discussion you were talking about before in the Forge Go channel. Let's just jump on to something a little bit similar, but maybe helpful for those that are kind of maybe new to the language. Do you have any, we kind of talked about it, but would you have some specific ways to make error handling look better? We have packages, we have some other things, but sometimes it gets, all the time. Do you have something that's better than that?
No.
Okay, so thank you very much.
Find the way it is. Do not there's a visual there's a visual style to code blocks. And Brandon note, I hate the assert packages. Every assert package that exists makes your tests look visually different when failure states.
He has an opinion. Okay.
I have a massive opinion on the assert packages, and I think there's nothing wrong with the fact that visually we see if error not equal nil. We see it a lot. That repetition isn't a problem. It's clarity and its consistency across code bases. And that's a feature, not a bug.
Everyone agree with him?
No.
That's okay.
Oh, whoa.
You don't have
Come on, bring it up.
Oh, me?
Yep.
Oh, I love Testify Assert. It's my favorite.
Well,
That's
Is that what you meant?
I'm talking about, that's an example of every use case I see for I'm trying to, even when your editors take that if error not equal nil thing and wrap it up into one like fake line, again, visually makes your code harder to look at a glance. My big problem with Testify and Assert is you, instead of just doing the normal, all of the equals and the comparisons you do in an if statement to find conditions, you have like a billion different bespoke functions for everything you want to check. And you have to say, well, I can't just say if this is equal to that or this is greater. I have to know all of this like massive corpus of function names to replace if statements, which we already know how to use all the time. Like half the people I talk to, like, do you know the difference how to in assert to do a fatal? Does anybody know? Like, so we can say assert x equal y. How do you do the fatal version of that?
Require.
Yeah, but
Takes a T as the
it's another package with a completely duplicated set of functions that half the people I talk to don't know. They're like, I don't know, they just do assert everywhere. They don't think about it, right? Sorry. That's
I just to take it back to errors. There's a common pattern you see where people just make a function called handle error.
Yep.
And they hide their if statement inside that function. That's what Carson's saying he doesn't like, because the nesting and the flow of having that if error equals nil condition close takes your eye through the error handling process and makes your brain read it.
I think are we good?
So that's.
Oh, yeah, I just want to add on to that
I
part.
mean, the assert was a side note. Go back to the errors, and I understand his point. I always do if. I don't care either way. I think you have to train yourself to think that way. But I personally, I also find that if flow makes my brain think harder about handling the errors.
Okay, when you exit, I want you there and then Carson that way. Go ahead.
Oh, absolutely. No, I just want to add on to that. I think if you're reaching for a handle error function, you should probably enforce cyclomatic complexity on a linter somewhere, and then just reduce your functions to smaller pieces and keep your ifs where they belong.
Yep.
I think you're reaching in the opposite direction.
Yeah, very good comment.
I do have a weird best practice that I think is that you should have nobody does this, but I like having a function called handle that you use throughout your entire application, because there's this thought process of what do I do with an error when I get to the top of the chain? If you get into main, if you get to the top of a defer, if you're inside of a concurrent function, like what do you do with an error? A lot of the people just hit log.println, and it might be log.println, but it might depend on what your team does. And so if like I had a company where we logged it in a specific way, if it's an error, if it was a 400 error, then we made it a warning. And if it was a 500 error, it's an error. And we also did a metric every time an error happened. And so we had just a function called handle that you passed all your errors to at the top of your tree. And then it handled it the same way every time. And you didn't have to, I think anytime you give a developer a choice, you're going to have bugs sometimes. And so you take away that choice of what to do if you give yourself a handle function that is just used at the top every single time.
That's a different point, Carson. He's not saying don't handle errors. He's saying at the end, let's make a path. I think it's a different. I think it's completely separate points.
You're not saying every time.
No, just when you get to the very top of the return, when you can't return.
When you get at the top, you do whatever you want. Yeah.
That handle function is still inside of the if statement.
Exactly.
You're still saying if error is not equal to nil. Handle.
If there's no return for error, what do you do?
We've handled this error.
Yeah, that's fine.
There we go.
All right. Well, we're out of time, but give a great applause to the great. Don't write an error.
True.